Hello everyone. In this video we will focus on factoring quadratics special cases. And in this first example it says determine the missing factor in x squared minus 81. So when we consider factoring in special cases, the first thing to notice is that we don't have a complete trinomial. We have ax squared minus c. Then we might notice that x squared is a perfect square and the root is x. 81 is also a perfect square and the root could be positive or negative 9. And as a result, we are looking at a difference of squares. Since the trinomial is not complete, the bx term is not there, and there's subtraction, this is called a difference of squares. So there's a special way to factor it. We don't need to use decomposition. We don't need to use product sum. We don't need to consider if a is 1 or if it's not 1. We could simply take the roots and it would look like this. So we open up our equal symbol. We write our equal symbol. We open up two brackets. And first goes the square root of x squared. Second goes the square root of 81. And in order for bx to cancel, one needs to be addition and one needs to be subtraction. And what I mean by that is, if we were to expand this, we would have x squared minus 9x plus 9x minus 81. And notice by having 1 plus 9 and 1 minus 9 in the binomials, it allows the middle term to cancel and become 0, leaving us with the standard form of x squared minus 81, and thus the difference of squares. So back to the original question, determine the missing factor. We have an x plus 9, so we're missing an x minus 9, which is choice D. And that concludes the first example. We found the missing factor using the difference of squares technique, which is a special case for factoring quadratics when they're in the form of ax squared minus c. Okay, let's consider the second example. Determine the missing factor in 12x squared plus 48x plus 48. And you could see that it is partially factored, and they divided out a common factor of 3. And we need to find the missing term, and we also a missing factor, and we also notice that it has an exponent 2 on the bracket, which means both factors are the same. Which means possibly after we common factor, we might have a perfect square trinomial, which is the second special case when factoring trinomials. So let's start. Let's first common factor the original expression. So we have equals 3 brackets, and we're going to take the 12x squared and we're going to divide it by 3 plus 48x, and we're going to divide that by 3 plus 48, and we're going to divide that by 3. And that allows us to common factor the 3 out of this trinomial, ax squared plus bx plus c. The resulting quotient is 4x squared plus 16x plus 16. And at this point, if we analyze a little further, the 4x squared is a perfect square, and the root is 2x, and 16 is also a perfect square, and the root is 4. And if we were to multiply these perfect roots, we'd get 8x, and if we times that by 2, we will get 16x. So we are looking at a perfect square trinomial in the brackets. So this is a special case. We don't need to use product and sum. We do not need to use decomposition. We can go straight into our factored brackets. we have an existing common factor of 3 that remains. We open up two brackets. We write the 2x first in each of them. And we write the 4 second in each of them. And because bx remains, 2x times 4 is 8x, and 8x plus 8x is 16x, it remains, so both of these brackets are addition. And this could be further written, more simplified, as 3 bracket 2x plus 4 squared. And as a result, we've factored this quadratic, which is a special case because there's a perfect square trinomial inside the bracket. At this point, we have a perfect square trinomial, which led us to the special case of considering the perfect roots. Okay, that concludes the second part, the second example. And to consider the choices above, we see that the 2x plus 4 missing factor is choice B. And that concludes this example, and it also concludes this video. Thank you for watching. Have a great day. You guys are awesome.